Okay, I'll just give a brief introduction about her. She has completed her PhD in Big Data Analytics from Gujarat Technological University, Ahmedabad, and currently she is working as assistant professor in Nirma University from 2011. So now today she is going to present on the topic called. Sorry, there is some technical issue. Yes, today she is going to take a topic on big data analytics and machine learning. So now I would like to request Jigna madam to please take over the session, and up to you, madam. Thank you so much for
Thank
accepting our
yes.
invitation. Yeah, please.
Thank you, Mr. Jugal. Good morning to the audience. I hope you learned about the basics of the big data analytics in um, previous lectures. I'm sharing my screen. Sir, Jugal sir, please give me sharing rights.
Yes, madam.
Give me sharing rights. I'm unable to share my screen.
Okay, so can you? The thing is, like, I already given permission. So what you can do is you can just disconnect and please rejoin the meeting.
Okay, okay,
Then I
okay,
think it should be possible. Yeah.
okay. Let me do the same. Good morning, all. Once again, I'm Jigna, working as assistant professor in Nirma University. Today, I'll be talking about the platforms, which are the platforms available to handle the big data, and which should be used for which type of application. About the same, I'll be talking today. Is my screen visible?
Yes, madam.
Okay, and I'm audible properly, is it?
Yes, madam.
Okay, okay. So, yes, if I'm just making it to the presentable mode. So I'll be talking about the platforms to handle the big data. As I told you, I'm Jigna. I'm working as assistant professor in Nirma University since 2011. I completed my PhD in the year 2019, and in the area of the big data, I have created the big data warehouse. So I'm knowing a bit about the big data, and that knowledge I'm sharing with all of you today. See, the objective of this lecture is to give you the proper guidance for selection of a particular platform. You can see, you can go through this particular image, and you will realize that the person want to climb up, and person is having the ladders too, but he don't know that how to use this particular platform, how to use this particular ladder in order to climb up that particular wall. So this is what is happening with all of us. We know Apache Spark, we know Apache Hadoop, we know Apache Pig, Hive, Spark, lots of platforms available, GPU, peer-to-peer network, HPC, lots and lots of platforms available to work with the big data. But we do not know that when to use which platform. So that is the objective of my today's lecture, that to choose the right platform for a particular application. And for the same, we need to analyze the need of the application, we need to analyze the need of the algorithm, and we need to apply the right decision. So that is what is the objective of today's lecture. I think I'm very much clear now. See, in the era of big data, like what happened, you must go through the basic definitions of the big data and few platforms also. May I know that how many platforms you studied in this previous 2 days? You can write down through the chat. May I know which are the platforms that you studied till now in the previous 2 days? Okay, anyways. So the thing is, again, I'm making it in a sharing mode. Okay. So even if you have learned one platform, two platforms, so which are the platforms available, and which platforms that you have studied? I'll be talking about available, all available platforms for the big data that I'll be talking about. But the thing is, like in the era of big data, like traditional data analysis platforms do not work, and therefore, to perform any kind of analysis on a complex data, or we can say very voluminous data, the scaling up the hardware and what we can say, the choosing a particular right hardware, choosing a particular right software, that particular that particular matter becomes very crucial for, if users requirement are we can say, like they are, if it is satisfied with a reasonable amount of time, that's good. And academicians and the researchers are working on, of course they are working on building a particular analysis techniques. Of course, as we all are the researchers, we want to do the research in the big data analytics. So we all want to, or we are in the way to find out the novel data analytic techniques for the big data. The academic industrialists or the professionals, they are identifying few right platforms, and we find the novel methods for the data analytics, isn't it? So that would be the continuous development of different algorithms. That would be the continuous development of the different platforms. Okay, so there are several big data platforms available with different characteristics. You would be having the different characteristics. You would be having the different systems. So choosing the right platform that required the in-depth knowledge. Of course, capabilities are we need to build the capabilities in order to work with these platforms. But for that, we need the in-depth knowledge, and we must ensure here that we are using the appropriate platforms to build the analytic based solution. Okay, so the first question is what, when the user, or when a particular client want to decide the right platforms to choose from available platforms, then that client or that user would investigate which application, which algorithms, what are the needs of the algorithms. Okay, so there might be a few fundamental questions, like first question is, how quickly do we need to get the results. Okay, suppose we are working on any of the healthcare problem, and we are going to solve it through the big data analytics. So the first question that is being asked by the user of the client, that what would be the speed of getting the result. Okay, what is the amount of time being taken by your algorithm, by your platform? That is the first question. Second question is, how much, how big is the data to be processed? How much data is being processed? That is another question, isn't it? The first is the time, the second is the volume, and the third one is, does the model building require the several iterations, or it can be done in a single iteration? That is one more question. How many iterations are needed? So these are the three basic fundamental questions. Using this answer to these questions, we would come to know that yes, this is the right platform for my application. Okay, because like when we see the Apache Hadoop, we'll see that to storing to HDFS, or say for example, on the storing at the OS level, storing at the memory level, again to look back into the OS level. So that is what we would see that when you are having more than one iterations or the several iterations, your model would require more time in building a particular, or yes, building this type of model, that would require a lot of time, as well as the efforts, as well as the complexity would be more. Okay, so these are the three basic questions that can be asked uh, by the user. Of course, these are the system needs. You can see these are the system needs. But when we concerns about the application, we concerns about a particular, what we can say, the algorithm, then the platform level, or we can say that the system level requirements, that has to be look into the concerns, like the first concern is, will there be a need for more data processing capability in the future? Isn't it? Once you have built up a particular model, you have deployed it, but as this is a big data, you may have the increasing amount of the data that can becomes um, in the future. So whether we need the data processing capability in the future too? So that is the first question, basic question for the platform level requirement or the system level requirement. The second is the rate of the data transfer is critical for the application. If we take the any of the platform, if we take the any of application, we would come to know about whether the data transfer are is very much critical, because in the real time applications, or in the real time data generation applications, um, the data transfer is very fast, isn't it? So there, we need to choose a particular platform that is suitable to this type of application. Third one is there a need for handling the hardware failures within the application? Yes. If my hardware get fail, if my hardware get fail, then is it possible to work with the what we can say without absent, or we can say with the absenteeism of a particular hardware, with whether my model, with whether my network would continue to work or not. So that is called as a fault tolerant too, isn't it? So these are all the basic questions that we need to ask to before choosing a particular application, before choosing before just analyzing the problem. So here we would come with the major things like scaling. Over here I've not mentioned the scaling, but here the scaling is what? Scaling is, we can say that it is the ability of the system to adapt the increased amount of the data processing, like increased demand of data processing that can be adapted if we are providing the scaling. So for you see, this scaling is what, like to support the big data processing, the different platforms that incorporate the scaling in different forms. So from the we can say like broadest perspective, the big data platforms that can be categorized in a two ways. The first one is a horizontal scaling, and the second one is a vertical scaling. So here the question is, what is horizontal scaling then? So horizontal scaling that involves the distribution of the workload across the servers. So that we need to remember, like horizontal and vertical scaling. Horizontal is like what, you are extending horizon in the horizons, okay, and vertically that is we can say like right now I'm explaining just horizontal scaling. So it involves the distribution of the workload across the servers, and that we can have the commodity machines, we can have the professional servers too. So it is also known as a scale out. We are scaling out, and that's why it is known as a scale out. And where the multiple independent machines that are being added together in order to process or in order to improve the processing capability. And here, of course, the multiple instances of the operating systems are running on the separate machines. So throughout this lecture, throughout this particular session, I'm going to tell you about which are the platforms under the horizontal scalings, which are the, because horizontal scaling and vertical scaling, these two things are different. Horizontal scaling and a vertical scaling, these are the two different concepts, but both of them are being used to scaling the ability of the system in order to achieve the increased demand of the data processing. So one to achieve the same is a horizontal scaling, and another is a vertical scaling. So vertical scaling is what? That involves the installation of the more processors, more memory, faster hardware, all of these things under a single server. So within a single server, this vertical scaling involves the more processors, more memory, and faster hardware. Uh, and this is what, like scaling up a particular, we are adding all these things, processors, we are adding all these things in a single machine, and that's why this is called as a scale up. This is called as a scale up. One is horizontally, one is vertically, and that's why this is called as the scale up. It involves a single instance of an operating system. There won't be like multiple operating systems, unlike the horizontal scaling, where you would have the more instances, multiple instances of the operating systems, and it is being run in a distributed manner where parallel processing is being done. But here in the vertical scaling, we would be having only the single instance of the in of a particular operating system. So now let us look at the advantages of the horizontal scaling and the disadvantages of the horizontal scaling, and then I'll be telling that yes, these are the platforms that comes under the horizontal scaling, and this about these platforms I'm going to teach. Okay, is all the things going perfectly? Am I audible? All the things are going perfectly? Is there any problem, doubt, or any questions for the horizontal scaling, vertical scaling, scaling, or like which are the system level requirements or the platform level requirements or the algorithm or the application level requirements? I talked in the talked about the same. Okay. So let us look at the comparison of the advantages and the drawbacks of horizontal scaling and vertical scaling. By looking at this, you would come to know that yes, horizontal scaling is what like increase it increase the performance in small steps. Even जितना आपको चाहिए, as and when it is needed, as and when it is needed, the it increase the performance. Or we can add machines, we can add the commodity machines as and when we require. Horizontal scaling, like we can say, financial investments, that would be very less because we are using, no, we are not using the very good platforms or very good servers or the professional high end or high end configuration wale machines इसमें use नहीं कर रहे. That's why like we are having only the commodity machines, and so that is the financial investments is very less compared to the vertical scaling. Yes. And drawbacks are what? Like, not all the softwares can be supported because we are having the distributed and we are having the parallel processing, and we would be having the more complexities. So, software has to handle all these things, and that's why um, there's what we can say. Not all the softwares are can be supported in a horizontal scaling. Even the limited number of software that are available, actually not because this is one more disadvantages which is added here. Not all the softwares can take the advantage of the horizontal scaling, and not all the softwares are available to do it. So that are the disadvantages. At the same time, vertical scaling is having the advantage of the same thing. That is vertical scaling. That means it works on the same machine, on a single OS. So on a single OS, most of all the softwares can easily can be used for the vertical scaling. That is one thing, and another is it is easy to manage, easy to maintain, easy to install the hardware with a single machine. In a single machine, you can install the hardware, and that would be the advantage of the vertical scaling. At the same time, vertical scaling is suffering from these other problems, because we need the financial investment in order to add the memory, in order to add some data storage, because it works on a single machine. So in order to add the high processing power to the single machine, we require a more financial investment. That would be the disadvantage. great disadvantage. We can say that thing. So system has to be more powerful to handle. Like yes, of course, as it is a single machine, as it is having few extension of the RAM, few extension of the memory as well as the data storage. Up to the certain extent, you can extend it. जैसे सारे slots उसके fill up हो गए, then you can't extend it, isn't it? So extension of what we can say the limited extension of this particular limited um, hardware is the drawback. Then the last one is, so it is not possible to scale up vertically after a certain limit. That is what I've explained because it is not fully utilized for additional performance. So that is also the drawback of the vertical scaling. By looking at this horizontal scaling and the vertical scaling, uh, drawbacks and the pros and the cons, let us go forward with the platforms available under each of the platform. Yes, horizontal scaling platforms are the peer-to-peer network, which is very old and very well-known network, or we can say the configuration of the structure in order to work parallelly. Okay. Second one is, sorry, Apache Hadoop. Third one is Apache Spark. Vertical scaling platforms are HPC clusters, multi-core CPU, GPU, graphics processing unit, and field programmable gate arrays. I'm going to explain about the peer-to-peer network, each of the platforms that I'm going to explain today. All these platforms can be used for the big data analytics, and then we'll see the pros cons of each and every platforms, and then we'll see a particular configuration for which type of configuration for which type of problems, which algorithm which platform needs to be used. And I'll be explaining k-means clustering for the for a different applications for of a particular that can be applicable to the all types of platforms, but that we need to just model it. Peer-to-peer networks. Do I need to explain peer-to-peer network, or you people know? Peer-to-peer network, that is like it involves the millions of machines that are connected in a network. And you know that it is decentralized and the distributed network architecture, where the nodes in the network, of course, nodes in the network, they are known as the peers. And sorry, sorry. And the peers that serve, of course, it, they can be served or they can consume the resources too. See, peer-to-peer network is the oldest distributed computing platform in existence. सबसे पहले peer-to-peer network आया था. Distributed सबसे, when you will learn, or if you have learned the distributed environment, you might realize that yes, this particular platform is the oldest platform in existence. And typically this type of message passing interface, or we can say like MPI, for the communication scheme that can be used to set up to communicate or to exchange the data between the peers. So here we can see that, you see, each of the node that can store the data instance and the scale out is practically unlimited. Because millions of the nodes that you can consider, you can include in the peer-to-peer network. So the over here peer-to-peer network, if you see by this what we can say this introduction, you would realize that major major problem or the major drawback of this type of setup is what? The communication between the different nodes. Broadcasting a particular message broadcasting a particular message in peer-to-peer network, that is very cheap, or we can say is very easy. But the aggregation of the data, aggregation of the results to the to from all the nodes, and to do the aggregation, that is more expensive. And in addition to this, these two things, the message which are sent over the network, uh, that is that is nothing but the broadcasting. Okay, so broadcasting, where we are using the message passing interface. Actually, message passing interface, I need not to talk about the message passing interface over here much, but with a basic thing like MPI is what it is, the software communication paradigm, and that has been used in for the several years, and it is of course well established and thoroughly debugged. And one of the main feature of the MPI, message passing interface, that include the preserving process. That means preserving process means the processes um, that can be live, or we can say yes, live, even if, or as long as the system runs, and we need not to read the same data again and again, like unlike other frameworks, other platforms like MapReduce. Okay, so this is regarding the MPI. And MPI, that is available with a many programming language. You can have any programming language that you will work with the MPI. And here the broadcasting that can be done. Of course, here MPI, or the message passing interface, that appears to be perfect for the developing algorithms for the big data analytics, but it has major drawbacks. Is like fault tolerance. It is having the drawback of the fault intolerance, because MPI does not, that these things you need to remember, that the MPI has no mechanism to handle the fault. And when we deal with the big data analytics, that if a particular machine goes down, then quickly quickly the another machine should be up in a fraction of seconds. Okay, so when we are using on top of the peer-to-peer network, when we are using MPI, where unreliable hardware like single point or the single node failure, that can cause the entire system to break down or shut down. So that is the problem, because this is not the fault tolerant. Okay, that is the problem of the peer-to-peer network. I mean MPI, because peer-to-peer network is a particular structure where we are using the communication protocol as an MPI. Programming and all those things are good, but as far as the big data analytics is concerned, the problem is a fault tolerant and a single point of failure. So these are the two major problems that you need to consider when you are dealing with a big data analytics, uh, as far as a peer-to-peer network is concerned. Second one is Apache Hadoop. Student, may I know, or audience, may I know that whether Apache Hadoop is being taught or not? Anyone can write in the chat. Apache Hadoop ho gaya? So I need not to talk in detail. Yes, Mr. Jugal or anyone? Do I need to teach the Hadoop? Yes. Hello.
Yes, man. Hadoop is a one types of platform. It provide the open source uh, framework.
Yes, sir. But I'm just asking that in the previous 2 days of this workshop, whether Hadoop is taught or not. Actually, I'm unaware of the entire schedule and what is covered in the previous 2 days. So, whether Apache Hadoop is taught, if it is taught, then I need to just tell about only the brief about the Apache Hadoop. And if it is not taught, then I can go into the detail of the Apache Hadoop. Okay, anyways. I'm just giving the brief introduction of the Apache Hadoop. I'm assuming that you know it in the detail. So I'm just brief. I'm giving you the brief about the Apache Hadoop because it is like open source framework for storing as well as processing the large data set using the clusters of community hardware. This is the basic definition and known by anyone. But here I'm supposed to teach you when to use Apache Hadoop. What are the problems of the Apache Hadoop, and what are the good of this Apache Hadoop? So actually, Hadoop that is designed to scale up to the hundreds, as I told you earlier, like horizontal scaling, the vertical scaling. So Apache Hadoop comes under the horizontal scaling part. Even peer-to-peer network also comes under the horizontal scaling. So you can scale up to the hundreds, millions of machines that you can join for the peer-to-peer network. Okay, in Apache Hadoop also you can have the hundreds of machines that you can, hundreds of community machines that you can add, and you can have your own network for the Apache Hadoop, and there you can have the application. But the goodness of the Apache Hadoop is what? See, it is having mainly two components. One is the distributed file system, and another is the YARN. That is what the resource manager. So resources are being managed separately through the YARN, and all the data that can be stored in the HDFS. Uh, there you'll be having the name node, data node, you'll be having job tracker, task tracker, that is in version 1, and then you'll be having the resource manager. These are all the different modules, names, components that are being used in order to work with Apache Hadoop. Over here, the goodness of the Apache Hadoop is it is highly fault tolerant, which is the need of the big data applications. So even if the single machine get fail, the Apache Hadoop is having more replication factors. The replicas are there. Uh, there would be like edit logs, and that can be being managed by the secondary name node. So their secondary name node would secondary name node would look after all the screenshots of all the working of the HDFS in the, and all of the components. And even if a single node gets fail, then using this logs and through this images, the secondary name node is capable to make a particular node up, or to add one more machine, one more what we can say node in within fraction of seconds. So that is the goodness of the Apache Hadoop, that it is highly fault tolerant, where you can use in order to work with Apache Hadoop. We can work with the map reduce programming framework. Uh, that is a programming model that can be used, and it is, of course, that is being given in the year like I don't remember exact year, but it was initially MapReduce programming was done at Google. Okay, like high level mappers that would read the data from the HDFS. Initially, data have been stored on the HDFS, Initially, the data have been stored on HDFS, and then that can be from the HDFS, the data can be read through particular mappers, and then mappers would do the mapping with the input data and the logical calculations, and then it would be given to the reducers where some aggregation functions or whatever the logic that you have designed for the reducers, that is being applied. I can teach you the Hadoop distributed file system in detail, mapper reducer, how to write down the logic for the different mappers reducers. If you tell that, I can tell you, but as I'm about to teach the different platforms, so if we'll get the time remains at the end, and if you are eager to learn about those mapper reducer logic and your problems, then definitely I'm going to teach you about that. Like HDFS, they are having very good concepts like the combiners and the partitioners, but there you might have the question like this type of framework is very complex, because installation of the Hadoop itself require a lot of time. It's a time consuming process, so that's why many people that they are finding the online versions, that there they can be used the Amazon Web Services, or there they can use this Docker images use karke they can install the Hadoop in their machines, and they can uh, uh, get the knowledge of the HDFS, how exactly the HDFS works, and how the yarn works, and then mapper reducer also. So here Apache Hadoop is one more platform in a under the umbrella of the horizontal scaling. Then the third one is Apache Spark. Apache Spark might be known to you. Apache Spark, that is like we can say for the data analytics, for the data analysis paradigm. Spark is the, we can say that is used nowadays mostly. अपाचे हडूप भी यूज होता है, अपाचे स्पार्क ज्यादा यूज होता है फॉर द एनालिटिक्स और द मशीन लर्निंग. As far as the machine learning is concerned, Apache Spark is being used mainly. Okay, and yes, it is being developed at the University of California at Berkeley, and it is designed to overcome the disk IO limitations from the Uh, just a minute. Uh, I'm taking a break of 5 minutes. I'm taking break of 5 minutes. Um, Okay, so somebody is asking me to teach about the Apache Hadoop, so I can tell about the Apache Hadoop in detail once I complete all the platforms. What is Spark and when to use which type of platforms. So quickly I'll go through this all the platforms and then I'll explain Hadoop in detail. So I was talking about Apache Spark. So Apache Spark is like it is of course like initially only Apache Hadoop was there, but in order to overcome the disk I/O limitations, like all the things are being all the data that can be stored at the disk level, and then the all operations that are done at the memory level, or so that input output or what we can say, the IO limitations, in order to overcome this IO limitations, the Apache Spark is been designed. So that's why it is having in memory computations, all the data that can be fetched into the memory, and all those operations are being done in memory only. So that allowed the data to be cached in the memory, whatever the data needed for the processing further, that can be cached into the memory. And that's why this would eliminate the problems of the Hadoop disk overhead limitations for the iterative task. So over here, I must tell you that for the iterative processing, for the um, machine learning type of algorithms, if you are working with like k-means clustering or the KNN or any other like SVM or CNN, जो भी अगर आप कर रहे हो perform कर रहे हो, तो you must need the Apache Spark instead of Apache Hadoop. Okay, that is one thing. Another is when you are using the deep learning model, that can be even not done in a Apache Spark. And for that, because it is like in the distributed environment, to do the deep learning is very much difficult and it's very much costly, and it is in the research. Till date, nobody has done in a particular parallel processing or the distributed environment. The deep learning model have not been done yet. So there, in the deep learning environment, you can go through the GPU. For the vertical scaling platforms that are being used for the vertical scaling, है जितने platforms है वो deep learning के लिए use होंगे. Horizontal scaling में peer to peer network and Apache Hadoop, that cannot be used for the iterative task. अगर machine learning चाहिए आपको, you must go through the Spark. Of course, you can have machine learning का कोई ऐसा algorithm है in which you need only the single iterations, then you must go for the Apache Hadoop. But when it is iterative task, go for the Spark. If it is a deep learning, go for the GPU. So of course, because Spark, that suppose a Java, Scala, Python for all the task. Even Hadoop also support the Python and this Java, because it is built in Java. It's being used there, and it is tested for the in-memory computation. It is 100 times faster than a Hadoop MapReduce. So this is Apache Spark. Then HPC cluster is also comes under the horizontal scaling platform. HPC cluster is what a high performance computing clusters, where you are having the supercomputers, where you are having the thousands of cores that can be used. So here, different machines, different supercomputers can have the different variety of disk organization. They can have the different cache communication mechanisms. So depending on the user requirement, this particular system's HPC clusters can be built powerful hardware which can be optimized for the speed, which can be optimized for a particular throughput. Okay, and because what happened, for the top quality high end hardware, the fault tolerance is must. Okay, and but here, when you are having the high end high configured machines, supercomputers हैं आपके पास, तो इसमें in there won't be any chances that it would go down. Chances would be less. In case of the Hadoop, in case of the HPC, in case of the peer-to-peer network, we are using the commodity machines. तो commodity machines अगर हम लोग use करेंगे, तो they are prone to fail, and that's why we need to provide the what we can say, the high fault tolerant mechanism. But in case of the HPC cluster, it is not possible. Okay, so HPC clusters are scalable as Hadoop or the Spark clusters. They are scalable as Hadoop. They are scalable as Spark clusters. But yes, they are having the limitations. They are having the limitations. So they are, because there we can have the hundred of machines that can be joined together in order to increase the processing power. जैसे आपको लगा, say for example, you developed or you designed a particular model which is capable of handling, let's say 20 GB of data. So once you have deployed it, and then you realize that yes, more 5 GB would come tomorrow, or more 10 GB would come tomorrow. So you can add two more machines and you just configure it, and the system is on. You can work with it. But when you are having the HPC clusters, or when you are having a single machines, you can have you can have the processing up to certain limit. So that would be the limitations. Then the multi-core CPU, see, these are the vertical scaling platforms now. Multi-core CPU is what? The one machine. We are talking about the one machine, and that is having the dozens of processing cores. And they see, every one of us knows that what is shared memory architecture, shared nothing architecture, and shared disk architecture. Shared disk architecture, where only the disk or only the storage things are being shared. We can have the same storage platform or storage capability, but accessing or the processing in the different machines. Shared memory, where we are having the same memory, where threading or the parallel processing that can be done. But you can have the shared nothing architecture too. You are not having them, you are having individual memory, you are having the individual disk, and using the individual memory, individual disk, you are processing the given task, isn't it? So the Hadoop is a shared nothing architecture. Spark is a shared nothing architecture. Multi-core CPU is a shared memory. Shared memory. Okay. So over the past few years, you would realize that CPUs that would have gained internal parallelism, like DDR3, DDR5. So that internal parallelism, like number of cores per chip and the number of operations that the core can perform, that can be increased significantly. And newer breeds of motherboards that allow the multiple CPUs within a single machine, that's why it would increase the parallelism significantly. See, until the last few years, CPUs were mainly responsible for only accelerating the algorithms for the big data analytics. And see, for the high level CPU architecture, that can be with the four cores, and that can be achieved through the multi-threading, that can be achieved through the parallelism. And there, all the cores that will share the same memory. And the task that can be broken down into the threads, each thread that can be executed parallelly on the different CPU cores. That is what is the main logic behind this. And most of the programming language that can be provide the libraries to create the threads, to create the CPU, or to utilize the CPU parallelism. Okay, so the number of cores per CPU that is we can say the सिंगल जीपीयू से इसमें सिंगल जीपीयू से इसमें ज्यादा होंगे as these are the multi-core CPU. Next is the GPU. Every one of us know what is GPU. That is the graphics processing unit. See, initially graphics processing unit था ना, that was designed to accelerate the creation of the images to images in a particular frame buffer and with a particular display output for a intended display output. But when GPUs were primarily being used for the graphical operations like video, image editing, gaming, but then GPU, that is general purpose computing on the graphics processing units, that is being developed, and GPU has the large number of processing cores, and typically, of course, 25,000 as on date compared to the multi-core CPU. And GPU has its own DDR5 memory, which is very faster than the typical DDR3, which is being used in the multi-core CPUs. So GPU is very faster, is good, but it's costly too. It's costly too because this is being designed by the NVIDIA and the CUDA framework, CUDA framework, that is being made for the GPU programming for all the programmers without going into the hardware details. Hardware detail के बारे में अगर आप नहीं भी जानते हो ना, but you know the CUDA programming, you can just go through it. Okay, so that is goodness about the GPU, and mainly GPU is being used for the big data analytics programming for we can say for the machine learning, for the deep learning algorithms. With this, let us go to the next platform, which is FPGA. FPGA is a field programmable gate arrays. Field programmable gate arrays, they are highly specialized hardware units for a specific applications. Um, like say for example, I want to design a sensor based or a particular hardware based application, big data application, where I need a customized model. Okay, so for the customized hardware, the FPGA is a most suitable platform because FPGAs that can be highly optimized for the speed. Speed, because it is not general purpose or generally defined architecture, isn't it? So it can be programmed using HDL. HDL is what? Hardware descriptive language. Hardware descriptive language, of course, due to the customized hardware and development cost is typically much higher compared to the other platforms. And then, of course, if we look at the coding part, or we must know the HDL, we must know like hardware specific language हमें पता होनी चाहिए कि hardware और कहाँ से कहाँ तक का कौन सा slot use किया है, what is the memory address of a particular or particular component. These things needs to be known when we deal with the FPGA, and FPGA it is effective only when we are having the certain set of applications. So of course this is being used in the real world applications. FPGA is very good for the real time applications. Say for example, network security. One of the example is the network security, like for this type of applications, FPGA that can be used for the hardware firewall, and the hardware firewall which is much faster, far better than the software firewalls for scanning the large amount of network data, and Of course, in the recent years, the speed of the multi-core processing are reaching closer to the FPGA. But if we look back to the 5-10 years ago, we'll see that FPGA were a very good solution for what we can say the real-time applications. With this, all these platforms, I hope I'm very much clear with the horizontal scaling, vertical scaling platforms. For the horizontal scaling, they are the peer-to-peer network, the Hadoop and the Spark. Vertical scaling, they are the HPC clusters, multi-core CPU, GPU, and the FPGA. With this introduction, with this brief idea about all these platforms and the basic configurations of all this, let me show you the comparison that when to use which one. Okay, so comparison of platforms. Initially, I started the lecture with the system level questions or the algorithm or the application level questions for a particular platform. There. Then I told you that whether a particular system is scalable or not, whether it is continue to work if a machine gets failed. These were the questions that, or how big is the data is to be processed, whether the rate of the data transfer is critical or not. Okay, so these were the few basic questions I've asked. We have understood. Now with this, with those questions, in context of those questions, these are the system level or the platform level characteristics that are being compared with the platforms. Okay, so scalability, data IO performance, fault tolerance. I need not to explain this definition because this is being already done. So look at this. When the scalability is the issue, when your application is need more scalability, when your application needs more scalability, then if you are dealing with a particular application, say for example, is the market basket analysis. Market basket analysis is the application. We know that we would be having a lot of transactions, and from those transactions we need to show that which are the frequent items bought together. Okay, for those type of applications, when the chain of the when the chain of a particular superstore or the market that is being extended, the data generated would be more. So that's why we can have what we can say the horizontal scaling. We can consider the horizontal scaling is good for that, and there won't be any security issues there too. So scalability, in case of the scalability, peer-to-peer network, virtual clusters, and the Spark. The second one is the Hadoop. The third one is the Spark. Fourth one is HPC clusters. Fifth is multi-core CPU, GPU, and FPGA. Look at the star rating. Look at the star rating, and we'll have a discussion on these things. I'll justify why 5 stars, why 3 star, why 2 star, and why 1 star. Just go through this, and we'll have a discussion on this PPT. Okay, let me look at the chat. Yes. Yes, dear faculty members, students, colleagues, scalability, why it is 5 star in a peer-to-peer network or in the Hadoop or in the Spark. But we can say exactly 3 stars for the HPC clusters, 2 stars for the multi-core CPU. And why it is given 1 star to the FPGA? Any answers? Any answers? Okay. Scalability is what? Scalability is defined as the ability of the system to add up the or to handle the growing amount of the work, growing amount of data load, processing load in order to matlab, so in capable manner. Okay. So in this type of scalability category, the virtual clusters, you see virtual clusters as MapReduce and peer-to-peer network and virtual clusters using Spark. These are the three things, these are the three platforms getting the 5 star rating because the systems are highly scalable. They are highly scalable because these two platforms, they're relatively easy to add the more machines and scale out the systems to any extent. कितना भी उसको आप scale out करो, it is possible to work with. So the HPC clusters, okay, 5 star is clear, like 5 star because they are capable to extend n number of machines. But in case of the HPC clusters, that is that can be used as a map reduce भी use कर सकते हो, मैसेज पासिंग इंटरफेस भी कम्युनिकेशन के लिए फ्रेमवर्क के लिए यूज कर सकते हो. It receives the 3 star, and the reason is because it is very much difficult to scale up the systems after certain extent. At certain extent you can extend to the certain limit, you can extend, but after that extent you cannot extend. That is the reason to get the 3 star. Because HPC clusters once because they are having thousands of cores, and once it is deployed they are expensive to scale up. That is one more reason to give the 3 stars. Multi-core CPU, multi-threading, 2 stars, 2 stars, and the GPU also get a 2 stars because scalability is not the strength of these two platforms, because number of GPUs on a single machine can have, and adding more machines that would create the data transfer bottleneck, we can say bottleneck. 1 star rating to the FPGA because once the FPGA that is deployed, developed, एक बार हमने this is customized hardware, customized application that can be built through the FPGA. So once it is being developed and deployed, scaling up and modifying the hardware is very costly and is too much expensive logically, as well as the financially too. Okay, so that's why it gets only the 1 star. I think I'm very much clear as far as the scalability is the issue for your application. If your application is having only the scalability, it requires only the scalability, go with the peer-to-peer network virtual clusters. If it is not the issue, you can have the FPGA too. Okay. Next one is the data IO performance. Uh, just a minute, again I'm sharing. Data IO performance. You can see data IO performance is what? The rate at which the data is being transferred to a peripheral device or from a peripheral device. So data IO performance, where you'll be having peer-to-peer network 1 star, virtual cluster with the Hadoop MapReduce is 2 star, with Apache Spark 3 star, HPC cluster 4 star, multi-core CPU 4 star, GPU and FPGA are having outstanding performance as far as the data IO performance is concerned. The reason over here is what, like GPU and FPGA, they are getting the 5 star because they have the high throughput memory. They are having the data IO operations are extremely fast. And the current generation of the GPU available with the DDR5 memory, which is the faster than the DDR3, that is system memory, that is the multi-core CPU. So HPC clusters and the multi-core CPU, they are fall next to this category because they are getting the 4 star, because the systems usually make the use of the system memory, and they are having this limitation. Reasonably, they are fast compared to the disk access, but in comparison with the DDR5, DDR3 is the slower. Virtual clusters using Spark receives the 3 star because Spark makes the use of the system memory, which is of course good than the Apache Hadoop. Virtual clusters using MapReduce over the Apache Hadoop. You can see it is having 2 star because it is having the network access with the bottleneck of the data IO. HDFS में से डेटा लो, रीड करो, वापस मेमोरी में आओ, प्रोसेस करो, वापस इंटरमीडिएट डेटा जो है आपका जनरेट हो रहा है वो वापस आप डिस्क पे डालो. So that is the data IO bottleneck. Okay. And you see the peer-to-peer network. Peer-to-peer systems they are the worst in this category because they receive only 1 star here, because systems that are use disk for the data access, and in addition to this, unmanaged and a complex network scheme that makes it very inefficient, or the aggregation of the results over a single node, and makes the network communication very much slower compared to the virtual cluster. And that's why peer-to-peer network, that मतलब with the message passing interface जो उसका है ना, that is adding the more limitations to the peer-to-peer network. Okay, so this is with the data IO performance. Then fault tolerance, you can see fault tolerance. Fault tolerance is what the system ability of the system to continue to operate properly, even if the system gets failed, even if the one node or the more than one node gets failed. So peer-to-peer network 1 star, virtual cluster 5 star, virtual cluster 5 star, and all other comes under the 4 star category, because peer-to-peer network there is no you can see there is no particular mechanism, built-in mechanism for the fault tolerant mechanism. And that's why they consist of and it consists of the commodity machines, so they are prone to fail, so they are highly susceptible to hardware failures, and that's why it gets a peer-to-peer network gets only 1 star. But you see the virtual clusters with a map reduce, virtual cluster with a spark, they are having the replication management, and they are, of course they are prone to fail, but they are having some built-in mechanisms. I'll call it as a double inverted comma built-in mechanism for this. Just a minute. So HPC clusters and the multi-core CPU, they are getting the 4 star because, uh, of course, they are very high end or high configuration machines. But once if they get fail, so there won't be any mechanism to overcome it. That's why they are getting the 4 star. Then the next one is comparison of the platforms for the application or the algorithm level characteristics, that is real-time processing, data size supported, and iterative task support. So if your application, which is the real-time, if it is the sensor based or if it is like a hardware configuration based where the real-time data is coming and you are going to give you the answer lively, so there real-time processing comes into the picture. Or data size, what is the size of the data that is being processed, or for the iterative task, if your task is iterative, then what to do. So these are the main three questions asked for the algorithm or the system level or application level characteristics. So what are the star rating which are given to all these platforms? Let us look at the first as a real-time processing. Yes, I see nothing is okay. Okay, for the real-time processing, real as far as the real-time processing is what, like certain time real time is what, like strictly results must come within some time constraint. So real time responses are always delivered in a milliseconds or sometimes a microseconds. So FPGA and GPU are outstanding, performing outstanding in the real time processing. Why? Because FPGA is what, like customized platform, customized hardware. So the processing cores for the GPU, the thousands of processing cores and the high memory bandwidth, that is most suitable for the real-time data processing. Okay, and for the FPGA, they are specially built, and that's why the speed and they are suitable for the real-time data processing. As far as the multi-core CPUs and HPC clusters are concerned, they are getting the 3 stars because they have the reasonable real-time processing capabilities, because they are not good as GPU and FPGA, but they are not as bad as peer-to-peer or the virtual clusters. So that's why they are getting the 3 stars. But yes, virtual clusters are getting the 2 stars. They say Hadoop or MapReduce real, they are not good for the real-time processing because they are slow in the data IO processing. क्योंकि HDFS पे डेटा स्टोर करना है, उसको लेना है और फिर बाद में उसको प्रोसेस करना है. So that's why they are getting the 2 stars. So if your application is having a combination of the scalability and the real-time processing, then you can compare both the stable and you can finalize the which platform needs to be explored. Okay, so virtual clusters in the virtual cluster spark, they are getting the 2 stars. Then peer-to-peer network, you can see the peer-to-peer network that would receive only the 1 star. And the reason is what? Because it is slow with respect to the real-time data processing due to this network communication overhead. Because in the peer-to-peer network, the message passing interface that is being used for the communication protocol. So they are having the network communication overhead due to this commodity hardware as well as this communication protocol. So that is the problem. Then the next one is data size supported. Data size is for the size of data set that system can be processed and handled efficiently. So in this type of category or in this category, peer-to-peer network that would receive the 5 star because they can handle of course even petabytes of the data also and theoretical that can be scaled out to the unlimited infinite node number of nodes. So theoretical it is possible, and that's why it's getting, sorry, it is getting the 5 stars. Virtual clusters, Hadoop and Spark, you can see the 4 stars because they are highly suitable for the iterative algorithms. Spark is, of course, not the Hadoop MapReduce. You can see then multi-core CPU, GPU, and FPGA. They are getting the 2 stars here because limited size of the data that can be supported by these platforms and GPUs having the limited onboard memory, of course, for the FPGA too. And that's why they are getting the 2 stars. The next one is the iterative task support. You can see iterative task support, which is very good in FPGA, GPU, multi-core CPU, and HPC clusters. Of course, Spark is also performing good, but when you see the peer-to-peer network and the virtual cluster using Hadoop MapReduce is very, they are performing very poor. And the reason, as I told you, like iterative algorithms cannot be easily modified in this platforms. And even if you modify it, it requires the data IO का जो problem है that is there. And yes, these are with this comparisons. Let us look at the advantages and the disadvantages of all these platforms, and then quickly I'll be go through a particular algorithm which is designed for the different platforms. Till now, any questions? In the comparison table जो मैंने आपको दिखाया और समझाया उसके अंदर कोई problem, or if you are developing any of the particular application and if you are facing, then I can guide you that yes, for this type of problem you can choose this platform. Yes. Yes, you can discuss any of the application where that comparison table that can be used. Okay. If no question, then let's go to the peer-to-peer network and the advantages, disadvantages of the peer-to-peer network, virtual clusters using MapReduce, So you can see that peer-to-peer network good for the big data, but the problem is it is a fault intolerant, and the communication is very poor. Communication mechanism, that is message passing interface, which is not suitable for the iterative algorithms, and communication wise it is very slower. So if we are having a very good application, which does not require whether it is fault tolerant or the intolerant, whether it is not iterative or not, so then you can go through the peer-to-peer network using virtual clusters, using MapReduce, or using Hadoop MapReduce is good for the scalability, is good for the fault tolerant, but it is not good for the iterative. It is having a limitation to handle. mm, matlab, time which is being taken to handle the large amount of data is more. Okay, then virtual clusters using Spark. The advantages are the in-memory computations. The data is cached into the memory. These are the advantages. And the disadvantages are it is not optimal for the real-time processing task. Yes, for the iterative task is good, but for the real-time processing task, due to the I/O problem, the even the Spark is not capable to handle it. Then HPC clusters is good for the fault tolerance, but it's very much expensive due to the scores and due to the high-end configuration servers. Okay. Next is the FPGA. FPGA is good for the optimized speed. It is faster, but disadvantages are expensive. The number of applications which is supported by FPGA is very limited, and the amount of memory is also the limited. Okay. Now the few basic questions that I would like to ask you: how will you choose one platform for a particular criteria if the criteria is amount of time? If amount of time is the criteria, then it is the real-time problem. For the real-time problem, you can choose the GPU or you can choose the FPGA. The reasons to choose the GPU is because GPU is good for the optimization of the speed, thousands of processing cores. It's a high memory bandwidth that uses the DDR5 memory. It is widely used in many machine learning algorithms, so it's good. For the GPU is the best choice, or we can say FPGA is the best choice for as far as the amount of time is concerned. Number of iterations, when number of iterations are more, then GPU is the better choice because elimination. Okay, of course you can have the Spark too. Apache Spark भी use कर सकते हो, GPU भी use कर सकते हो. As far as the fault tolerance is concerned, virtual clusters, message passing, or the MapReduce programming, or the Spark, all those things are good. Okay, virtual clusters is the best, what we can say, virtual clusters is the best choice. Multi-core CPU, GPU, FPGA, peer-to-peer network, all these things are good for the fault tolerance. As far as the scalability is concerned, virtual clusters, peer-to-peer networks, they are the good choice. Choice of the platform through the data size, speed, or applying a model. Now, let us look at briefly look at a particular algorithm, iterative algorithm, how it works for the different platforms. Say K-means clustering algorithm. All of us knows that it requires, as it is a clustering algorithm, as it is the unsupervised learning algorithm, we need a few data points initially, then we need to say that how many clusters you want from this data set. So we would be having the data points D, and we are giving that I want 5 clusters, I want 2 clusters, I want 3 clusters. So number of clusters and number of data points that are given as an input. Then how to how to do the clustering here. So first of all, the centroids that are being initialized, then each of the data points that is being associated with the nearest centroid, and for that calculation of the centroid that is being done. So then recalculation the position of the centroid. So we would be doing step 2 and 3 till there are no more changes in the membership of the data points, and then output is the data points with the cluster membership. That is the output. Now K means on the mapper and reducer, you would be having the mapper and you would be having the reducers. It's nothing but the divide and conquer approach. Divide is what, like mapper is will do what the mapping with each of the data points with the centroid. So that would be the mapping task, and the reducing was the new centroid calculation that is being done. But here, what happened? New center is that could be stored on the disk. Again, from the disk, the mapper would take it. Again, the reducer would find out the aggregated or the new centroids that is being kept on the HDFS. Mapper would read it. So this process is the iterative process, and that can be done till we are getting no change in in the difference. Okay. So you can see the complexity of the mapper reducer for the k-means. And if the message passing interface, it's okay. You would be having a master slave architecture. So slaves that would read the part of the data, and when master broadcast the centroid to the slaves that would calculate the closest centroids to the data instances, and they would also compute the new local centroid and the local cluster sizes. Okay. GPU, GPU, that is like a simple program that you can do, like upload the data points and multiprocessors, because parallel processing that can be done here, the multiprocessor that would work with the one data vector and with the closest centroid. All these things are being mapped, and centroid recalculation that can be done on the CPU. So this is how all the platforms and the comparison and one algorithm that I've explained how it can be designed for the different applications. So I think done from my side. If any doubt, questions, queries from the platform perspective for a particular application where I can help, please let me know.
If anyone has any questions, please ask, or you can even write in chat box. It's fine.
Okay, over to you, Mr. Jugal.
I guess there are no questions. If any questions come, I will just let you know. Else, I think the session was very nice and informative. And thank you so much,
Thank
ma'am,
you.
for accepting the invitation.
Thank you, sir. And if any of the participants need the PPTs or need any of the further guidance for their application, I would be available on my email ID. I'm writing the chat. You can note it down. And if any of you want further help for your research work or in your MTech work or any of the project, then it would be I'll be feeling great to help you out. Jigna.patel @ nirmauni.ac.in. That would be my email ID.
Okay, ma'am. And the
Thank
thing is,
you.
like, anyways, the whole session will be on YouTube, so anyone wants to see, they can even access that. So yeah, thank you so much. And dear participant, we'll be starting our next session at 12:30.